Okay, I can now see myself right. So, hi everyone, and welcome to another session. So today we'll be solving again, we'll be solving two problems today, and after that I'll be giving a couple of homework. So today the number of questions in the homework will be more. It will be, I think there are 5 problems for your homework. So try to solve them, right? And the problems are pretty easy. Like it will be just modification of whatever we are doing, whatever we'll be solving in this class. The LRU cache problem, however, it's a bit interesting, but again, like I have also discussed LRU cache, you can find in this channel itself. So if you want to learn if you're not able to solve yourself how to solve LRU cache problem, you can look into this channel, and I already have a video on this, so I'm not discussing this again, right? It's for your homework, you can try it on your end. Yeah, so I'll wait. Okay, I think it has been loaded, so yeah, that's good as well. Yeah, let me know if you have any problem, if you have any doubts, or otherwise we can start with the class. Anything that you want to ask me, any questions or doubts that you have? I hope the problems are added to the description. I'm not sure. Okay, it's not added, I'll get them added, but again, like just keep a note of the problems and I'll get them added to the description. All right, any questions that you have, anything, any doubts, anything that I can help you with? But before that, let me know in the chat like if you guys can hear me properly, or I can actually test my audio as well. Yeah, I can hear myself, but yeah, like let me know if you guys can hear me properly and everything is fine. Then we can start with today's class. All good. Okay. uh, Unable to solve kth smallest element in the array. Mohammed, can have you actually looked into the solution for like there is a technique, maybe try searching for this instead of searching for the solution. 1 second, is this not connected? It's connected. Okay. Instead of searching for the solution, search for this technique that is called median of medians, right? So there is a video by God of Sen as well, you can look into that. Other than that, there are multiple articles on this as well, so you can read from there as well. Median of medians technique, right? So if you are unable to get, I'll actually do a special class today. Will not discuss, but again, we need a special class for this, a complete class for this, because this will be a big problem. I'll then arrange for a special class where I'll just discuss on the kth smallest element, how to find that. Or otherwise, like I'll just do that, right? I'll just schedule a class, and in that class I'll record a video where I explain how to solve the kth smallest element problem. I hope that that's fine. You will get some idea about that, right? So we'll do that. Other than that, let's start with today's question. So the problems we'll solve today is, first we'll solve reverse a linked list. After that, we'll check if the linked list is a palindrome or not. Then after that, you have a few homework for yourself, so we'll discuss it briefly around that. If there is something difficult, I'll try to explain that. Other than that, yeah, I'll just give a few homework. So yes, so first problem is, given a linked list. It's pretty simple. The question itself states that reverse a linked list, right? So you are given a linked list, you have to reverse it, as simple as that. So you are given a linked list of n nodes. The task is to reverse this list. Now you are 1 2 3 4 5 6, right? You have to convert this to 6 5 4 3 2 1, right? So basically this is what you have to do. You are given a straight linked list, you have to reverse it. That is, 6 comes first, after that 5 4 3 2 1. So you're basically reversing the linked list, right? Similarly, 2 7 8 9 10, it will become what? 10 9 8 7 2. So the output should be 10 9 8 7 2, and this should be the final linked list, right? So if you look into the expected time and the space complexity, it is order of n and order of 1. Okay, let's see how we can solve this, right? The brute force way of doing this will be definitely, like, you can use something like a recursion maybe, and that will definitely work. Other than that, what you can do is you can definitely go for n square loops, or you can definitely, like, what we have here is we want order of n time order of one space, right? We have time space complexity and time and space complexity as order of n and order of one. Now there are multiple ways to solve this, but in most of the cases the time complexity will be either n or n squared. The space complexity will be at least order of n, right? Or it might be order of one, but then the time complexity will overshoot to n squared. So we have to do this optimally, like both order of n time order of one space. How we can do this? So we'll look into that, right? So we will not create a new linked list, right? We'll try to change on the original linked list itself. Let's see what is the information that we need to carry forward, right? So 1, 2, 3, 4, 5, 6. Now let's understand the problem, like why cannot we just iterate forward, and why that's challenging, right? Definitely we have to iterate forward and do it, but again, like why it's challenging, let's understand that. So when we come to 2, right, when we come to 2, what do? We assign the next of 2 to be 1, right? After that we might maintain a pointer having the next of 2, like let's say this is broken, so we might have a pointer with this reference, but again, like when we move to 3, we again need the reference to 2 back, which we have lost already, right? So that's actually a problem. I'm not sure if you've understood this, but again, like just to explain this again, what do we need, or this will actually demonstrate like what do we need as well for the algorithm to work. So let's say we are at 3, right? We are at 3 and we have already reversed this part. We have already reversed 2, and this part also we have reversed, right? So we haven't reversed yet, so 2 to 3 this bond is still there, but we have to reverse this, right? So when we reverse this, what will it become? It will become 3 will point to 2. 3 will point to 2, right? It will become like this, right? It will become like this, or it can be like 4 will point to 3 as well, whichever you want to do. So 3 will point to 2 here. Now when you move forward, right, now you'll move forward to the next of 3, that is you will come here. A problem is you have to reverse the linked list, right? So when you come here, what you essentially have to do is you have to connect 4 and 3, right? So you have to remember, like we have a single linked list, right? So there is no way to traverse back. So you can definitely run a loop again and come up to this point, but again, like these paths have been reversed, right? So that will be challenging. So what you should ideally have is you should also ideally maintain, when you move to 4, you should also ideally maintain a pointer to 3, so that you can convert the next of 3 to be next of 4 to be 3, right? So this link will be broken. But when this link is broken, how do you move to 5? So when you are breaking this link, you should ideally also maintain another pointer that will point to the next node, right? That will point to the next node. So what are the 3 things that you need? What did we identify again? Let's just do this again. So the problem statement is reversing a linked list, right? So 3, 4, 5, 6, this was the linked list. Let's say we are reversing what? We are reversing 4, right? We are reversing on 4. So these paths have been reversed. Okay. When we are reversing 4, what do we want? We want the next of 4 to point to 3. Next of 4 to point to 3. So the next of 4, how would we point to 3? We should maintain a pointer to the previous node. Only in that way we can point it to 3. Otherwise, if you look into this part is disconnected from 4, and also 3, like this is reverse connected, right? So it will be difficult for us to come back to 3. So we have to do next of 4 equals to 3. So this, if we maintain this pointer, we can do this. But when we do this bond will be broken, right? The next bond will be broken. So we also need a pointer that will store what is the next node will jump into. Once this connection is broken and the next of 4 is made 3, we can directly move this pointer to this position using with the help of this pointer, and this pointer will come to the wherever this pointer was, right? So it will come to 4. And now see what we'll do. We'll do the same thing again. We'll maintain a pointer to the next node. We'll delete this. We'll place the next of 5 to be the previous pointer that we have here, and then we will move this pointer. We'll move this pointer to this position because we already know where this is. So in its place, and this pointer will be moved to the next position, right? So we already have a pointer here, so it will be moved to the next position. Now here again, it will be made like this, right? It will be like this. So this is how we'll do, and for the first element, the next will be made null. Right, so it will be made null for the first element, and this will become the head as well, right? So this is how we can reverse a linked list. Okay, so the algorithm is pretty simple. We have to maintain three things. First is, when we are at a node, we are assuming that we have already reversed the previous nodes, right? So when you are at 4, we are assuming that we have already reversed 1, 2, 3, and that should be reversed, right? Now at 4, what do we need? We need a pointer at 3, that is the previous node. We need a pointer at the next node, that is 5. Now what do we do at 4? We'll break the relation between the 4 and 5, that is the next node. We'll mark the next of 4 to be the previous node, wherever the previous node is, which is 3, and then we'll continue our search from, we'll move the previous node to the current node, and we'll move the current node to the next node, that is 5, right? So that's how we can reverse a linked list. So we'll need 3 pointers to perform this. Okay, let's write the code for this. Let me know if you have any doubts in the logic, and I believe, like, if you have some doubts, mostly it will be cleared through the code as well. So let's actually look into this first. So node start, I think we have to use struct. Node star, current equals to what? Current equals to, so first is if head of next is null, right? If head of next is null, we'll just return. So if head of next is equals to null, just sorry, head of next is equals to null, then just return, right? So we have a size of at least 2. We have a size of at least 2. So we'll start from the second point, right? So node star current equals to what? Head of next. So we'll start from the second element. Node star previous equals to head, and we will do current of previous and head of next. Head of next, we'll set this to null first, right? We'll set this to null. Okay, its next will be null. Now we'll do while current not equals to null. While current not equals to null, yes. While current is not equals to null, what do? We store a temporary node star next node will be what? Current of next. We'll store this because we'll break the bond of current of next. We'll change current of next, right? So what will current of next point to? Current of next will point to what? It will point to previous node, right? It will point to the previous node that I have. Now current of next is pointing to the previous node. So what can we do after this? We have to move the pointers now. So how do we move them? First, previous has to be moved to current. So previous moves to current, because in the next iteration, the current will move to the first next position. The previous will move to the wherever the current is right now, and the next will be the next position, corresponding next position, right? So and current will be moving to next node, right? So finally we have reversed it. So we'll return the previous node, because we have reached null. So the previous node will point to the last node basically, right? So we'll return the previous node, and that should actually reverse it. Let's see actually if I have missed something. So let's try to run this. Okay, head of, return head. Compilation node star. Okay, node star will not be there. So struct node star, and here also struct node star. Okay. Oh, I'm doing in C. I should have used C++. That's fine. So yes, we have reversed, I believe. Yes, we have reversed the linked list. So let's submit. I hope there is no corner case. Can there be? Yeah, I don't think so. Yes. So we have solved this, right? Anyone has any doubts with this approach, like how we are solving this? It's pretty simple. Like what we are doing is, as we are going forward, we are reversing whatever we have seen till now, right? So basically at every iteration we are reversing the current node, and the previous nodes are already reversed, so the current node is reversed, then the entire, from beginning to the current node, the entire thing will be reversed, right? So at every iteration we are reversing. So what do we need when we reverse? We need a pointer to the previous node, right? We need a pointer to the next node, and what do we do then? We break the current next. The current next will be pointing to the previous node, so the previous node has been current node has been reversed. Now the move to the next node, what do? We move first previous to the current node, and current will move to the next node, right? So any doubts with this? Anyone has any doubts with this? Pretty simple code. And the time complexity, how much? It is order of n, because we are just running one traversal. The space complexity is order of 1, because we are just maintaining 3 pointers, so it's just order of 1, right? Anyone has any doubts? All right, let me know if you have any doubts. We can move to the next problem. The next problem will be a bit difficult than this, I believe, but let's see. Okay, so the next problem that we have, is you are given a check if the linked list is a palindrome, right? So what we have to do is, we are given a single linked list, right? We are given a single linked list and it has n integers. The task is to check if the given linked list is palindrome or not. What is palindrome? If something looks the same from forward as well as backward, right? So for example, what is an example of palindrome? Mom, MOM, right? So if you read it forwards, if you read it backwards, it's the same. Similarly, dad, DAD, right? So it's also a palindrome. So you are given a linked list and you have to tell whether it's a palindrome. So in this case, see, 1 to 1, it is a palindrome, right? If you read it forwards, it's 1 to 1. If you read it backwards, it is 1 to 1. 1 2 3 4, it is not a palindrome, because if you read it forward, it is 1 2 3 4. If you read it backward, it is 4 3 2 1. So it's not a palindrome, right? So expected time complexity is order of n. Expected space complexity is also order of 1, right? So we have to solve this. Let's see how we can do that, right? Okay. What is the property of a palindrome, right? What is the property? It should read same from front and back. So if we think about it more carefully, 1 2 3 2 1. If you see, this is a palindrome. And how do we check for a palindrome? Basically, for the first half, right? For the first half and for the second half should be a reverse or a mirror image of the first half, right? Only then it can read same from front and back. If you see 1 and 1, it is kind of a mirror image, right? So 2 comes here and 2 comes here. So it is kind of a mirror image. So basically, what is a palindrome? If we redefine a palindrome will be such that the first half will be equals to, like, let's say 1 2 3 will be equals to the reverse of the second half. The first half will be reverse to of the second half. So 3 2 1, let's say, is the second half. So if you see, the first half is reverse of the second half, right? And this will basically be a palindrome, right? If we merge them together, 1 2 3 3 2 1, if we merge them together, it will be a palindrome, right? 1 2 3 3 2 1. So it is indeed a palindrome, right? So it's a palindrome. Now there are two cases, right? Here there are two cases. First is when the length is even, right? When the length is even, we can break it into two parts. And what can we check is, the first half is equals to the reverse of the second half, right? When it is odd, when the size is odd, like let's say 1 2 3 4 3 2 1, in that case also we'll break it into two halves, but one of the elements, the middle element, will be left out, right? And we have to again check, like, the first half will be equals to reverse of the second half, and that is what we have to check, right? So this is the logic. So the logic will be pretty simple here. What we have to do, we have to identify, like, we have to first go to the middle point, right? We have to go to the middle point. Now we will break our linked list into two halves, right? Half 1 and half 2. After that, what we'll check? We'll check if half 1 is equals to reverse of half 2. So we have already learned how to reverse a linked list. So we can reverse the linked list quickly and we can check half 1 is equals to reverse of half 2. Everything will be done in place, right? Once that check is performed, what we can do, we can again half 1 and we can add reverse of half 2 to up to the next of half 1, right? So we can quickly add this as well. So this is what we can do. So first we'll break it into two halves, half 1, half 2. We'll check half 1 is equals to reverse of half 2. Once that is done, we'll again bring back the original linked list. So for bringing that back, what we'll do, we'll merge them together, right? Half 1 will be merged to reverse of half 2, or there might be another node B in between. So half 1 will be merged to B, B will be merged to half 2, reverse of half 2, sorry, R of half 2, right? So this will be the logic for checking if two linked lists are palindrome. And everything will be order of 1. We have already seen how we can do order of 1 space solution for reversing a linked list. Checking if the linked list is equal, it's also order of 1. You just have to run 2 pointers. What we have to do is we have to detect the middle element. So detecting the middle element will also be order of 1, order of n time. So the total complexity will remain order of n time, order of 1 space, right? So let's try to write the code for this. But here we have to be a bit careful with respect to like even size and odd size. So we have to be careful around that, but that's fine. So node star first equals to head. Okay. First is if head of next is null, right? If head of next is null. Let me see. Okay, C++ is there. If head of next is null, that is the size is 1, right? So we'll just return true that a single element is palindrome, right? So node star first equals to head. Node star second is also equals to head, right? What we'll do here is we will try to find the middle position, right? We'll try to find the middle element. Now let's actually understand for two situations like odd and even. What we'll do is we'll do similar to a fast pointer slow pointer approach to find the middle point, right? But we have to identify like for both even and odd what will be where do we end up, right? So let's see that. So let's say 1 2 3 4, that's the even length, right? So what do? We start here. Now the slow pointer moves by one position. The fast pointer will move by 2 positions, right? So the fast pointer will move by 2 positions. In next iteration, the slow pointer will move by 1 position. The first pointer will move by 2 positions and it will reach null. So we have basically reached the second point of the second half, right? The first element of the second half in case of even. In case of odd, let's see 1 2 3 4 5, right? Okay, we start here. Now what do? We move by 2 places and 1 places. So this will move by 2 places. This will move, the top will move by 1 place. Again, this will move by 2 places. This will move by 1 place, and where we end is at 3, right? We end at 3, that is the middle element itself. So what generally we want is we also want for this slow pointer, we also want the previous element, right? In both the cases, we want the previous element. So let's have that as well. But one thing to maybe we want to do that, I'm not sure, but yeah, like if the size is 2, let's get rid of that case as well, right? If the size is 2, so if head of next is also null, right? Size of 2, let's get rid of that as well. Is equals to null. In that case, we'll check if the first and second elements are same. So head of val, head of data is equals to head of next of data. So that will be the condition, right? So we'll just return head of data is equals to head of next of data. We'll just make this check, right? Otherwise, so we are done with the 1 and 2. Now the size is definitely greater than 3, right? So first pointer will start from head of next of next. that is the fast one. The second one will be the slow pointer, that will be head of next, and node star previous of second, so it will be head, right? So while first of next, first not equals to null, while first is not equals to null and first of next is also not equals to null, in that case what do? We move second to by one place. Second equals to second of next, second equals to second of next, previous second is equals to previous second of next, and first equals to first of next, right? Now there are two conditions. First is even and odd. In case of even, we see that it reaches the end, so first is equals to null, that means it is even, right? This is the case of even, and we'll segregate the similar paths out later on, else it will be odd, right? Else odd. So whatever is similar, will segregate the will remove those things out, right? So first thing that we'll take care of is reversing a linked list, right? So that we have to take care of. So yeah, what can we do about reversing a linked list? So void, or yeah, void maybe or what can we do about reversing the linked list, right? So let's return node star only. So node star reverse, and we are given a node star head, and we have to reverse the linked list, right? So let's I've closed the solution, right? So we have to write it again. Let me know if you have any doubts still here. Anyone has any doubts? Okay, node star head will start. So what do? We maintain a previous equals to head, right? Previous equals to head. Uh, head of head equals to head of next. Previous of next is null. Previous of next equals to null. Previous of next will be null, and while head not equals to null, in that case what will do? Head is not equals to null, that means will store the current nodes to next node, sorry. So next node will be equals to head of next. Now head of next will be equals to previous equals to head equals to next, right? Finally what do? We'll return previous, so that will be the final one. So return previous, head of next not equals to head of next equals to null, and head not equals to null, in that case, right? So if head of next is equals to null, that is also needed. Head of next is equals to null, return, right? Okay, we have this now. Okay, let's start. So node starting of first will be what? Head. Ending of first will be what? Ending of first will be previous of second, right? Previous of second. And starting of second will be depending on this part, right? If it's even or odd. So okay, node star starting of second, node star starting of second. And do we need to mark the ending of second? I don't think so, so we can skip on marking the ending of second. Let me just see if the reverse part is correct. Node head of next is null, and return previous, yes. So I think that should be okay. So starting of second is what? Starting of second will be equals to, we don't know that yet, so we'll not assign anything. Ending of second is not needed right now, right? So anyways, let's actually do them separately only. I think that will be, that's not very complicated. But again, like, let's just do them separately. So for the event case, uh, it will be equals to second, right? It will be equals to second. It will be equals to second, right? Node start ht of second. Now what we'll do first thing we'll do is, it's a event size, right? So st ending of first of next equals to null. So we'll break the bond first. Now we'll reverse, right? So st of second equals to, we'll just reverse. What do we reverse? We'll reverse the st of second. We'll just reverse that. Now we'll also have another check, like if equal, right? So let's have a check here. Bool is equal, and we'll take 2 pointers, node first, node second. It just checks if two linked lists are equal. So while first of next not equals to null and second of next, well, both will reach null at the same time, not equals to null, if first of data not equals to second of data, in that case just return false. Otherwise first equals to first next, second equals to second next, and finally will return true if they are equal, right? So if they're equal, we'll return true. So this will basically check if two linked lists are equal or not. So we'll reverse, we'll check bool check equals to is equal. Which two are equal? Which two will be equal? The two of them that will be equal will be starting of first and starting of second, right? These two should be equal. And now what we'll do ending of first of next is equals to, again we'll reverse, sorry, ending of first of next will bring back the original linked list. So reverse st of second, will again reverse it, and will return check. That's for the case of even. Now for the case of odd, right? Now for the case of odd, what do we have? Okay, so we have node start, starting of first will be the same head. Node start ending of first will be also the same, that is previous of second. Node start starting of second, right? Starting of second, this will be a bit different. Starting of second will be equals to what? Just remember, where did second end? Second ended at the middle element, so it will be next of the middle element. So second of next, right? It will be next of the middle element, and node start st second. Now what we'll do, we'll first break all the bonds. So ending of first of next is null, and also ending of second of next is also equals to null. Second is the middle element, right? Is equals to null, right? First we have broken everything. Now we'll do st of second is equals to reverse st of second. We'll reverse the second part. We'll again check, bool check is equal to is equal, right? Is equal, are they equal? Which one? St of first, the starting of first and the starting of second, if these two linked lists are equal. If they are equal or not, it doesn't matter. So ending of next, what we'll do, ending of first, its next will be equals to second. Second's next will be equals to reverse. We have reversed the second part, so st of second, it's reverse st of second, and finally after that is done, we'll return check, right? And finally, let's although it will never reach here, but let's just return false here, right? So this will be the total code. Let's run this. compilation error. If head of next, which one? Return head. Okay, return head. Compilation error en first. Okay, en first next. In the line 88. Okay. Next. All right. Let's see if this is working. Okay. Let's submit. Okay, 544. Our output was 1. How is it 1? 544. So what should happen? Like, let's just print everything, right? Let's just print everything. 544 is the test case, right? 3 544. Compile and run. Okay, we are getting a 1. So let's see why we are getting a 1. So let's add some logging statements here. 544 is definitely odd, right? 544 is definitely odd. So let's see out everything, right? So starting off first of data, ending of first of data, I think for length of 3 it might be a bit problematic. I'm not sure. First will be head of next of next. Okay, second will be head of next. That is 4. Yes. Previous second will be head. Yes. So previous second will be head. Now while first not equals to now first of next. Now it will stop there, right? Previous of second will be indeed that. So yeah, I think that should be okay. Ending first of data and starting second of data. Let's have these 3 things and finally end it, right? So let's test again custom input, compile and run. Okay, we have 5. 5 is starting of first. Starting of first is 5. Yes. Ending of first is also 5. That's true. Starting of second will be 4. Yes. So that's actually true. How is this check working then? Bool check. First second, while first of next not equals to null. Oh, okay. First not equals to null and second not equals to null. We are checking on the next, but it should be first, right? So first not equals to null, second not equals to null. I think that should solve the problem. So yeah, our logic was correct, but only that part was wrong. So let's get rid of that part and run it again. Anyone has any doubt with the logic? I believe we can submit now. Okay, it's done. So any doubt with the logic? Anyone has any doubt with the logic? Any doubt with the logic? I understand the code is a bit long, but if you think about it, it's not very difficult, right? It's just I've created methods out to reverse a linked list and to check if 2 linked lists are equal. So for palindrome, we found out that when we are going to the middle point, there will be 2 cases, even and odd, right? So in case of even, we break it down into 2 parts. Now we reverse the second part, right? We reverse the second part, and then we check if the 2 linked lists are equal, and after that we have to restore the linked list as well. So we do ending of first of next will be deferred of st of second. We'll reverse the second part again so that it comes into original form, and we'll club it with the first part, and so that the original linked list is back, and then we return check, right? For odd, however, it's a bit different. So what we have is we break into 2 parts, but essentially it is broken into 3 parts, right? The middle element is separate. So what we do is first we break into 3 parts. We compare the first and the third part, but before that we reverse the third part. So we are reversing that part, and after that, after everything is done, after the check is done, what do? We the first will be connected to second, like the middle element. The middles next will be the reverse of the second, because the second has been reversed, right? So we'll reverse it back again to bring it to the original shape. So finally that's done, and then we'll return whatever is the check value, right? So that's how you can check if two linked lists are palindrome. What is the total complexity? All the loops, if you see, they are just order of n, like it's a single traversal. So order of n time. The space complexity will be order of 1, because we are just maintaining pointers, right? And we are changing everything in place. So it's just order of 1 space. Anyone has any doubts? Let me know if you have any doubts on this. Meanwhile, let's discuss the problem for homework. So the first problem is add 1 to a number that is represented as a linked list. So what you have to do is, you are given an n-digit number that is represented as a linked list. You have to add 1 to it. So 4, 5, 6. If you add 1 to this, it will become 4, 5, 7, right? 1, 2, 3. So just consider the case, like here the corner case will be 9, 9, 9. So if you add 1 to it, it will be 1, 0, 0, 0. So how would you tackle that, right? The space complexity is order of 1, time complexity is order of n. That is what you have to do. Second is space complexity order of 1 means that you cannot do recursion, right? So you cannot do recursion because it will use the stack space. So that's also not, you cannot do. Second is reverse a linked list in groups of given size. So we have already learned how to reverse a linked list. Here you will be given a group size k, and you have to reverse in group size of k. That is, let's say k is 4, so you will reverse the first 4 elements, and then you will reverse the next 4 elements, like that, right? You will be reversing in groups. That's It's also pretty simple, like just modification of what we have discussed. Third is add two numbers represented by linked list. So you are given two numbers that are represented by linked list. You have to add them up, right? So you have to add them up. The time complexity is n plus n. Space complexity will be max of n comma m. So I think that this is also pretty simple. You just have to go bottom up approach, right? Fourth will be, actually you can use a stack here, I believe. Sorry, stack. You can use recursion here, because the space complexity is permitted, right? Uh, Finally, we have rotate a linked list. It's pretty simple. You are given a single linked list. Your task is to rotate, left shift the linked list by k places. So k equals to 3. That means what will happen? It will be left shifted by 3 places. So first left shift will actually bring 8 to this point. Second and third 8 will be coming here. Just think about this 8. In the first left shift, everything will be shifted to the left by 1 place. So it will be what? It will be 4, 7, 8, 9, 2. After second left shift, it will be 7, 8, 9, 2, 4. After third left shift, it will be 8, 9, 2, 4, 7, right? So like this, 8, 9, 2, 4, 7. So if you return this, space complexity, time complexity order of n, space complexity order of 1. It's also pretty simple, like it can be easily done. uh, Fourth is a bit challenging. It is LRU cache. So what you have to do is, you have to implement LRU cache. Now I have already discussed that in, you can find the video in this channel itself. So in case you are not, I'll definitely recommend you to try it yourself. And if you're unable to do, then you can definitely refer to the video, right? So just refer to that video. Okay, with that, that brings us to the end of this session. Let me know if you have any doubts. Otherwise, we can end the session here and just complete the homework as well. Any doubts? All right. I don't think you have any doubts. Okay. All right then. I'll be seeing you guys in the next class. So thank you guys for joining in, and complete the homework definitely. And I'll see you guys in the next class.